My name is Felix Davis. I'm a product line manager in the IoT group at CISCO. And we've been building network infrastructure for the transmission and distribution grid from roughly about 2010. And we have smart metering deployments today, large scale at British Columbia Hydro in Canada, Duke Energy, First Energy, a number of other customers. And I'd say our key message around our smart metering deployments is that the vision that a lot of these utilities have is that smart metering is just a foundation for building an overall smart grid solution. So they're taking kind of more of an architectural approach to designing the smart meter solution so that one, it can give them future proofing to add on more use cases over time and make it a multi-service network. And two, they can adopt open standards to reduce kind of vendor lock-in and reduce their total cost of ownership. So a number of speakers have talked today about the challenges utilities are facing, integration of renewable energy, electric vehicle charging, government regulation, targeting the reduction of SAIDI, there's a lot of load control, demand response. There's a lot of new requirements and demands on utilities to build that are driving the need for more of a real-time communication system and more of taking an architectural approach instead of looking at use cases in silos. There are a lot of benefits to, and these are general trends within the IoT industry, a lot of benefits to adopting digitization around asset monitoring and management, becoming more predictive, things like transformer monitoring, energy conservation, so volt-var control, conservation of voltage reduction, reducing line losses. There's also safety and security for the workforce and moving from security by obscurity to IT-based security systems. And then lastly, building more resilience within these systems themselves to adapt to changing conditions, the impact of renewable energy. So all of these things are leading towards more interdependence on use cases. So utilities are starting to not look at just smart metering as meter reading only. They're seeing its impact and how it has on the distribution operations of the grid. We talk about things like power outage notifications, power restoration notifications to help during storms and outages, better detection of faults within the grid. Also, demand response, load control, but also the impact of integrating solar inverters and other devices onto more of a canopy, a multi-service canopy. And adding more services like quality service, you can prioritize different types of traffic over the same network infrastructure. So within utilities, what we're starting to see is they're starting to reduce some of the barriers operationally between the groups. You have metering operations groups, distribution operations groups, you've got IT, you've got security, you've got telecom. In many instances, they don't talk to each other. But now, with the deployment of smart metering, these barriers are starting to come down and you're starting to look more holistically and around an architecture for smart grid. So this picture kind of breaks it down more visually. Instead of deploying siloed approaches, deploying security 3 different ways, one for smart AMI, another one for distribution automation, another one for renewable energy, and so on. Moving to a converged IP architecture, so a converged architecture on internet protocol. We've been doing converged networks for decades in enterprise and service provider networks. Now we're leveraging those same protocols over now to the OT side. So now you can get the benefits of designing a common holistic security architecture that gives you future proofing to add on more and more use cases, but having a common way to do device authentication, authorization, encryption, all those kinds of services. And breaking it down from proprietary protocols to standards, things like WISUN. So for RF mesh networks, we're now seeing the industry starting to demand an interoperability. So that's what we've worked on within WISUN to drive interoperability for RF mesh networks. So, again, now with the drive to need for multi-service networks, it puts more demands on the network infrastructure. So there's more demands for resiliency within networks, so high availability for routing self-healing networks, quality of service I mentioned before, security, putting digital certificates on all the endpoints and having a secure PKI infrastructure, distributed intelligence, so having a hybrid approach of centralized versus distributed control. So putting intelligence on the network infrastructure and even on the meters themselves So you can do local command and control, data report by exception filtering, protocol translation. So meters are becoming general purpose sensors now to help with state estimation, figuring out which meters are behind which transformers, on which feeders, behind which substations. And then utilities are also moving from reactive to more proactive network management. So you can proactively figure out faults in the network and also do zero-touch provisioning for easier deployment. So this is a network diagram of a multi-service field area network. Another message is that there's not one communication technology that meets all use case requirements. Utilities are going to be deploying a mix and match of Wi-Fi, cellular, RF mesh, power line communications, low power, wide area wireless, a lot of fiber, Ethernet, private LTE. There's a whole range of different communication technologies, and they're often needed based on different use case requirements, different geographies, different regional regulations. So what we're trying to do is build a common architecture, again, on IP, so you can have a common way to do management, security, quality service, regardless of the physical communication technology. Okay? So, thank you very much.